electric circuit. Okay, now we're gonna quickly draw the picture version of this one. How can you draw the picture version of this definition of electric circuit?
Maybe.
So we start with a triangle. Okay. And what are we gonna put in the triangle? Terminals. So we have two terminals, positive and negative. So positive terminal and negative terminal. What else we gonna have? We're gonna call it voltage. Voltage. What else we have? Current. Okay, so current.
Resistors maybe?
Current goes from positive to
negative.
From positive to negative, and
maybe
a resistor. Okay. Now we're gonna write the equation version of this definition of electric circuit. What would be the equation? Anybody?
V equals I over
I
R.
is equal to Q over T.
Oh yeah.
Right?
Oh!
Okay,
Yeah.
now I'm gonna draw a road. Okay?
So
This is a road.
yeah, okay.
Alright, so we can call it, this is point A, right? This is point. We can call it positive terminal, we can call it
Negative.
negative terminal. Can we do that?
Yeah.
Alright,
The
so
cars are like the charges flowing.
so how can I measure the flow of car? Flow of traffic. Flow.
When I see it, how many cars pass from A to B in a certain amount of time.
Is the flow of traffic the speed of one single car from A to B?
No.
Is the flow of traffic is the speed of one car from positive to negative?
No.
What is the flow of traffic?
The flow of traffic maybe is
I
This
think it's
car-
all the cars.
Not all the car. This car,
all the cars.
Oh, the number of cars
number of car.
between A and B.
The number of cars are passing between A and B in a certain amount of
Good.
time.
Wow.
Number of car. Okay. What is the flow of charge?
Oh.
What is the flow of charge?
The number of charges that flow from terminal positive to terminal negative.
Okay. Number
a
of
given
not
amount of
car.
time.
Number of charge. Let's say 140 coulomb. 140 coulomb. It takes 1 minute for 140 coulomb to pass through from positive terminal to negative terminal. 1 minute.
So
Okay, find the current. Again, I'm going to explain it. It takes 1 minute for 140 coulomb to pass through from positive terminal to negative terminal. What would be the current? Quickly tell me.
140 over 60.
140 coulomb over
60 seconds.
6 amps. You must say the unit. Okay, now there is a question. What happened if I remove the voltage? Okay, this is a valid question. People always ask me what happened when I remove the voltage. Let's start with the Alex. What's your name? Alex?
Yeah.
Alex or Albert?
Alex, Albert.
Okay.
I think it's Albert.
What happened if I remove the voltage?
It stops the current.
Can you it stops the current? Can you elaborate more? Who can elaborate more? What's your name?
Steven.
Excuse me. What's your name? Isaac?
Isaac, yeah.
Yeah.
And Steven is the correct one.
Why? Why is this?
The atoms have to break through. They have to break through the atoms in the wire that lets them pass through.
Okay.
And they constantly get supplied energy by the voltage. And when you take away the voltage, then the current has an unbreakable wall that they cannot pass through and just gives up.
Made of what? Copper. The wire made of?
Copper.
The electric circuit made of wire made of?
Copper.
Copper. And copper made of?
Atoms.
Atom. Okay? So, the charges goes from positive to negative has to overcome the
Resistance.
barrier created by
Resistance.
atoms. The barrier that created by
Atom.
atoms. Okay? Does that make sense?
Yeah.
If you remove the voltage, what happened?
They lose the battle with the atom.
They lose the energy. They lose the energy to overcome the barrier created by
Atom.
atoms.
See, that's what I
Oh.
Very good. No, you said correct, but you are not only a student in the classroom, so
I
be
see.
careful. Okay, there are 34 students in the classroom, so you should not be only one person talking all the time. I know you are like, you should not be in this class anyway. Okay, so now another question. That question is, what if the temperature go down?
Oh, I have an idea.
Oh,
The resistance
If you
goes
have a
down
if you have a low voltage, how you can still light up the bulb?
by lowering the temperature.
By lowering the temperature. What happened with the atoms? If the temperature increases, atoms become noisy.
Yeah, they just move all over the place.
Creates the wall.
Yeah, and
Yeah.
it creates a very strong barrier. When they are still, they get like soggy, and the atoms can easily punch through them without losing a lot of energy.
If temperature go down, what happened? Atoms
Sleeps.
Yeah.
take rest. Atom take
Right.
Right.
So
rest.
they just
They
stand there.
they sit on the couch, and sometimes they fall in,
Sleep.
or sometimes they take nap. When they take nap, why they take nap? Temperature go down, they sit on the couch, they take nap.
Yeah. So then it's easy for the charges to punch through them because they're not making noise everywhere.
With a small voltage.
Voltage.
Yeah.
So you can have less voltage.
Because the less voltage is still kind of enough to supply the charges with enough energy to break their barrier.
Very good.
Oh.
Now the lesson.
What about the other
understand.
32?
Resistor.
Oh,
Okay,
what
there are
kind
two-
of the lesson is this? Can you write?
Lesson. There are two types of circuit.
Series and parallel?
Yeah. Series and parallel. How do you spell parallel?
P-A-R-A-L-L-E-L.
Parallel.
Wow.
Series circuit. There are three rules for series circuit. Let's draw for series circuit. Well, I'm gonna give you the rules and you're gonna draw the series circuit.
I think
Okay.
that-
Number one, the current.
Has one pathway?
The current.
Has
Well, current has one pathway. Okay. Current is same across the,
entire
Circuit.
and then you're gonna write the math formula for that. Number two. Number three.
Yeah, because resistor gives resistance.
Yeah.
So that's one of the basic.
Well, that's
What's a
not true for
resistor?
parallel. Okay, number one.
Hmm.
Current not same across the circuit.
Because there's different pathways, different amount of charges or atoms on each pathway.
Voltage same. Number three. Resistor increase, resistance
Decrease.
decrease. Alright, now I want you to draw the diagram for series circuit and diagram for parallel circuit. You can pause the video and you draw it. Okay, now you check with me. The series circuit just like the one we have.
Yeah, just a rectangle, only one current pathway.
One path to the
Negative terminal.
one path to the R1, R2, R3. One path to the what? One path to the, so the electron has one, the charges have one path. An electron has one path. Does that make sense?
Yeah.
Electron carries the charge, so it can carry only how many way? One
One.
way. Alright, now let's draw it for this one.
A parallel would have multiple resistors
Pathways.
and multiple pathways. So like one,
So it would like branch off, right?
2,
Ah.
3, like this.
Yeah.
And then let's draw the positive
And then.
R1, R2, R3. Okay, now look what happened.
Mm-hmm.
The charges goes from positive to negative, right?
Yeah.
Okay, it goes over here and over here, and it breaks, right? This path is break.
Okay.
Then this one will be what?
Broken.
This one will be broke, and this one will be broke. An example for this one is Christmas tree.
Oh,
If something wrong with the one light in a Christmas tree,
all of them.
all of them go out.
Because it's a series circuit.
It's a
It's
series
all
circuit.
in one line.
That's
So
right.
if the current fails in one, then it will quickly travel to all the others.
Right.
And in 1 second, bloop, no more lights.
All right.
It's like Christmas star.
Okay, so the charges starts moving and find that this path is broke.
Okay.
Currents, charges come back and try to find another path.
Oh,
And try to find another path.
It's
So
like
there are
a-
multiple paths of the charges.
it's like a maze.
Yeah.
It's like a maze, or it's
Okay,
like
the resistors are dead ends.
example, home or office. Okay. All right. The AC circuit that we have at home is a parallel circuit. Okay. Now, axis split. Told me that if you remove the voltage, what happened?
The charges stop flowing.
Yeah.
Or
The current ceases.
current ceases.
Right.
Okay, current ceases because the atoms create the barriers.
The atoms create the barrier, and because there's no voltage to supply the charge with
Energy.
it's a permanent barrier that the charge just gives up on.
Mm.
Always just
So what do you call that phenomena?
resistor.
Resistance. What do you call this phenomena?
Resistance.
Can you explain it again? If voltage removed, if you remove the voltage, what happened?
Then the atom will become unbreakable in the wire because the voltage doesn't supply the charges with the energy they need to break the atom.
Okay, so this is analogous to what?
Oh, friction.
How do you say that?
Resistance is the electric analog of friction.
Good. Resistance is the electric analog of on the road. What happened? Marble will eventually stops because there is a friction on the road, right?
The road is bumpy, so there will be at least some form of friction, and it's made out of concrete.
Friction. We understand friction, right? Thanks to
Yes.
Newton. We have the circuit. If you stop, remove the voltage, what happened? There is atoms. Atom creates the barrier, but the charges don't have energy.
To flow through
Charges won't have energy to overcome that.
barrier.
Alright guys, see you tomorrow.